Hello, today I'm going to create a print and place ball bearing that can be 3D printed. We're using Onshape to create it. So we start by creating a document. We have to give it a name and we call it print in place bearing. Once this has loaded, we will going to create a number of variables to control and parameterize. We need the outer diameter. We will need the inner diameter. We will need the width, and all of these variables have been length variables, but we need one more, which should be a number variable, which is the number of balls. So we call it n, and here we can, like always, we can set the value now or we can set it later. So in order to set a value later, we can either double click and change the value, or we can right click and choose edit. Once the variables are established, it's time to think about the design intent. First, the orientation. We want to 3D print this, so we do not want to reorient the model. Next thing we have to think about is the method. Since it's a bearing, it would be good to revolve the different pieces, and this means the outer and inner ring will be modeled by rotation. The ball itself will be modeled. The diameter of the ball will be established by using the constraint solver. And now we see we have some kind of dependency here. Because of this, we need to use the same sketch for the rings and the ball, because they're dependent on each other. Once this is done, we're gonna create the balls in a rotational array, and the number here is given by the variable n. At last, we're going to create some clearance, which will depend on the printer and the material and the settings of the printer and so on. We will now draw the sketch, and since the rotational plane of the bearing is the top plane, we can draw the profile on either the front plane or the right plane. I choose the front plane, press N. Now we get to name a feature. This is a very important step, and we call this rotational geometry. Now it's time to establish some construction geometry for mirroring and rotating and dimensioning. This will be our rotational and dimensional axis, and here we will have a mirror axis that will be a rotational axis for the balls as well. For the body of a bearing, we will draw a rectangle like this. It should be coincident with the y-axis in this case, and then we dimension it. Since we now have construction lines, we can use a feature of Onshape, which is diameter dimensioning, like this. And we have the variables, so this is the outer diameter, and this is the inner diameter. And since we have this construction line as well, we can use diameter dimensioning for the width as well. You see everything is black, so the sketch is fully constrained. Now we need to establish the position and dimension of the ball. We start by drawing a circle with a midpoint constraint here, which is the body of a bearing. Instead of dimensioning the diameter, we will draw two construction lines from the origin. They should be tangential to the circle. The second one can be mirrored from the first one. And since we want to fit 10 or n balls in the bigger circles, we dimension the angle between these lines to 360 divided by n, like this. You see, it will be 360 degrees. Again, this sketch is fully constrained. What is left now is some cleanup work. We need a gap in the body. So we draw a construction line from the center of the circle to the outer edge. And we draw a line which will be parallel to this one, which is not a construction line, down to the circle. Make sure it's parallel, and we can dimension this one, let's say to 0.6. It's not critical in any way. And then we mirror this one as well. What we need to do now is some cleanup. We need to trim away this and this and this and this, and we need to mirror the geometry of the bearing rings. Now we are ready to actually create the parts. We start by selecting the inner ring and the outer ring, choose a revolve, and the revolve will ask us for axis, and this axis is established here. Rings, we should name our parts as well. This is the outer ring, this is the inner ring. We hide these parts for now, and we make our rotational geometry visible. What we need to do now is create the ball. We do this by selecting this area. Again, we will revolve, and this time the rotational axis should be this one. So here we have the ball with the right diameter. Rename the part to ball, and we can rename the feature as well to ball. What we need to do now is make the clearance between the balls themselves and the rings. And the good tool to do this is the thicken tool. We select the surface of the ball, we choose remove, and a good value for this is maybe 0.12 millimeter for my printer. We call the feature clearance. Having done this, we are now ready to make the array of balls. To do that, we choose a circular pattern. The entity to pattern is the ball. The axis of the pattern is this center axis, and we need n instances. Okay. You see now there is a little bit of space between the balls. This is because of the clearance. And if we show the rings, our bearing is almost finished. It's time for some finishing touches. One thing we need to do is giving the edges a small fillet or chamfer. Oh, 0.9 is way too big, we try 0.1. It's good. And in order to make this printable as a print in place, we need to make a composite part of it all. Select everything we see. When we change this to closed, all the separate parts will be merged into those, so we cannot select them anymore. So now this should be finished.